Hey everyone, this is Brendan Smith, sales engineer with Iguazio. We're really excited to take part in the April event, which is model serving for AIIA. Um, I know when we talk about model serving, GPUs isn't something that is the first thing people want to talk about, but I figured most of you probably know the basics of model serving, and you would want maybe to talk a little bit about something more advanced and where things might be going, as opposed to some of the more basic, day one type stuff. So today I plan to talk about model serving with GPUs and why that's a good thing in certain use cases. Some of the pain points associated with using GPUs overall, when you would want to use them, when you'd want to kind of stay away from them, and some of the newer trends we're starting to see when it comes to serverless and how to utilize these GPUs in different cloud environments. So first and foremost, why GPUs? GPUs typically, when you're talking about them in the machine learning context, you're talking about training, right? So when we talk about what GPUs are good at, there's tons and tons of processing, units on these things, more so than a normal CPU. These were designed to basically be able to do, massive parallel computing. So the first GPUs are actually called graphics processing units, were designed for just computer graphics, basically playing video games on a computer. Nowadays, they've been modified a little bit, and the processing units on these GPUs are more general purpose. So it's not just for computer graphics, you can do other calculations on them. This is where we start to enter into, our domain as data scientists, which is, using them for machine learning type tasks. And that is very interesting because now you've got this piece of technology that was built for throughput, whereas CPUs don't handle throughput very well, not at the scale we're talking about. So when we talk about why you would want to use a GPU versus a CPU, you have to think about throughput versus latency. So training, let's just talk about training for a moment. Training a model with, thousands and thousands or even millions of images, you're talking about a lot of throughput there, right? But in training, you don't care so much about latency, right? It's going to take hours. That's fine. You're going to wait for your model to be trained. Latency is not really a concern. The opposite of that is CPUs, where latency is, typically what they're better at, and throughput not so much. So where that comes into play is when we talk about the deep learning applications, right? Training neural networks, you're definitely going to be using GPUs to do that. But what happens when you try to deploy that model and serve it, let's say, even online, right? That throughput is going to allow you to be able to serve much bigger models, much deeper neural networks than a CPU could, or you would even want to try to. So basically, that deep learning application is really where GPUs start to shine. And it's not just for training, it's not just for batch. We're talking online inference as well. And serving those models with GPU resources underneath of them is going to give you a huge leg up. And in some applications, you might not even be able to realistically, in a production environment, serve those same models with CPUs. So when we talk about throughput versus latency, especially when it comes to online serving, there's a balance to be played there, right? Because when you're training, it's just as much throughput as I need. I don't care about the latency. This is a lot different than serving, because now you have, customers or users, and someone's actually waiting for that result, right? Someone's on a website or they're on their phone, and you don't want your application, which is, classifying an image and, going to return some output to the user. You don't want that taking a long time. Latency does matter for that. So there's a delicate balance to be played for online inference when using GPUs between throughput and latency. You want to basically, define what the latency requirements are and see how much throughput you can realistically, capture without waiting too long, right? So This is a little bit more difficult than training, where you have sort of a known input at a known time. Hey, here's thousands of images. Go ahead and train the model. Online, it's, hey, thousands of images could come in a minute, and then the next minute, like, nothing comes in, right? It's varied. So finding that appropriate batch size to maximize the throughput and the utilization of the GPU while also maintaining latency requirements for the application, that's really important. And that's kind of the main game when we look at utilizing GPUs to serve these deep learning models. And then finally, the framework support for these things. So all the popular frameworks we're using today, like TensorFlow and PyTorch, they're coming with GPU support already built in. So, years ago, programming around GPUs was much more difficult and lower level, even though, NVIDIA has been providing, these libraries to work with. It was much lower level and more difficult to programmatically, do what you were trying to do. Whereas nowadays, the popular frameworks have essentially, wrapped these lower level functions, and you almost just get it for free, right? Like, you start using TensorFlow, it's got built-in GPU support. So you're not really worried too much about what's going on underneath of that. You just know that they're utilizing, NVIDIA's different APIs to programmatically operate with that GPU for you. So today it's gotten a lot better, and I think things are going this way more and more, right? So companies like NVIDIA are, pushing more towards optimizations, even for inference, not just for like batch sort of use cases, but for inference as well. And they just keep on optimizing things. The popular frameworks know that they have to keep up and offer that, or, users will find other frameworks that do offer it, because GPUs just can't be ignored at this point. So I think that's a pretty good overall summary of like why you would want to use a GPU and in what application. And specifically, it's going to be deep learning, right? Your neural networks are going to be the ones you want to use these on. And then, of course, some of the balancing acts you got to play with throughput versus latency. Now, it's not all sunshine and rainbows. There are lots of pain points. Not as bad as they used to be, but they're still there. Utilization of a GPU is very nuanced. So there's really two different takes on this, right? There's a model and its utilization of one GPU, and then there's the GPU and it being shared among multiple models or resources or users. Both of those things are tricky and not as clean as using a CPU. So if you have a model and it uses a GPU, GPUs are expensive to keep up and running, right? So if you're in a cloud hosting environment and you use one of the instances that have a V100 or T4 or something like that, I mean, it costs a good bit of money. So you want to make sure that while it's up, you're fully utilizing it. You don't want to bring something up that's expensive and then have very low utilization on it. So, being able to essentially utilize that resource to its potential can be difficult in some use cases. And then also when it comes to sharing, so typically, a model will take up a GPU and it's pretty much assigned to that model. It's not something that gets shared easily. So, utilizing large clusters of GPUs in an enterprise with tons of different models, tons of different users and resources requesting use of GPUs, that can be a little bit tricky. There's products that have come out that that help with that, and the cloud platforms are getting a little bit better at it, but it's still not quite sunshine and rainbows yet. As far as automation, I hear this a lot. People just to work with the GPU and get it up and running and get everything deployed, it can be difficult. It can be daunting, and some people just stay away from it, right? So, especially on the data science side, you usually have to get MLOps engineers involved, and then it's all this, cloud infrastructure stuff going on, and people just kind of go, oh, this is too much. Having a way to, bring those resources up automatically would definitely help out. And then finally, cost, right? And cost is kind of linked to these other two pain points. GPU resources are just more expensive than CPUs. I mean, apples to apples, they're just more expensive. So making sure that you're utilizing that resource, making sure that that resource is being scaled when needed automatically, either down or up. That is going to go to great lengths to reduce cost and make the cost efficiency a lot better for your GPUs. Another thing to mention is GPUs, the power consumption is actually a lot less than CPUs. Not so much in the consumer graphics cards, right? Those tend to run a little bit hot. But when we talk about the commercial applications of GPUs, they tend to compute per watt much less than CPUs, which is good for ecological reasons, right? Everyone's trying to go green, use less power. There's a really interesting white paper that NVIDIA put out in 2015. It's called GPU-based deep learning inference, a performance and power analysis, where they actually show how efficient, from a power perspective, these GPUs are when they're computing. So you could probably just Google GPU-based deep learning inference NVIDIA and find that and take a quick read. So with those pain points, one of the things that would help out with that is if we had like a serverless framework that you could use with GPUs, right? That would help with optimization, that would help with automation, being able to automatically spin up, functions that had GPUs attached to them, being able to scale out those functions. So if I had something where, the needs of my application needed more instances of that function requiring more GPUs, I want to be able to do that automatically. I want to be able to scale that out. And so this is something that's very tricky to build, but here at Iguazio, we built it. It's our open source project called Nucleo, and it's a serverless platform where you can actually attach GPU resources to serverless functions. The nice thing about it is it's not cloud specific, right? It's because it's not an AWS Lambda function or an Azure function. It's cloud agnostic, and you can even use it on premise as well. So with that, we hope to alleviate some of those pain points that I mentioned earlier. So I hope this short talk gave you something to think about when it comes to using GPUs with model serving. It's not just for offline. It's not just for batch. You can do online inference with GPUs, and it's a great for deep learning applications. If you have any questions or you want to chat about what you're doing with MLOps today, you can come check us out at iguazio.com. And if you want to check out that awesome serverless platform I talked about earlier, it's called Nucleo. You can check that out on nucleo.io. We'll see you next time. Thanks, everybody.